Hello everyone, here is another Olympiad maths problem. So this is actually testing our understanding of certain concepts of mathematics. Basically, if you watch this, you would see that this is actually a very simple example. So what is this? So you can really see that in the numerator that this is actually difference of two squares. And you recall that by the rule of difference of two squares, if I have x squared minus y squared, it is equal to x plus y multiplied by x minus y. Okay, so that means that the numerator is going to be 2023 squared minus 1 squared, which is equal to, okay, so, and the implication of that is that we will get 2024 multiplied by 2022. Okay, so, and if you watch now, you would see that that means that our 2023 squared minus 1 all over 2022 is simply equal to 2024 multiplied by 2022 all over 2022. Okay, so and quickly you can see this will take away this. So the solution to this is simply equal to 2022. Right, so in this quick example, we are asked to evaluate, that is to find the value of x for this problem. So this is, of course, a solved problem. So what are we expected to do? Of course, you cannot rationalize this, even though it's a fraction, because the numerator is having a root all over everything there. And so you can see your 2 plus root 5 under a cube root. So the best thing to do here is to cross multiply. And if we do that, we are going to have of course, I'm going to get x will multiply the denominator to give me x into 1 plus root 5 to be equal to, of course, on the other side, I will have the cube root of 2 plus the root of 5. Okay, so what do I do next? Now, the next thing is to clear the radical on the right-hand side, take it to the left-hand side. So if this cube root comes over to the left-hand side, it turns to a cube. So I'm now going to have x into 1 plus the root of 5. Okay, and then on this side, I will just have 2 plus the root of 5. Okay, so what can we do next? So we will try to evaluate the bracket, and if we do, that is going to give us, of course, by the rule of indices, we are told that ab raised to the power of n is the same thing as a to the power of n, b to the power of n. Okay, so that means that the power 3 can come on x, and then it can also come on 1 plus the root of 5. Okay, and this is still equal to 2 plus the root of 5. Okay, so at this point, I will try to, here will also be to the power of 3. So I'll try to now expand that bracket, and that is going to give me s raised to the power of 3. If I expand this, take your time to expand it. Of course, you are going to get 16 plus 8 root 5. That's what it's going to give you, and that is equal to 2 plus root of 5. How did I get that? Of course, you can expand by either by binomial process, or you can expand using expanding it into 3 brackets, where you have 1 plus root 5 into 1 plus root 5, then into another 1 plus root 5. So by the time you are done expanding these 3, you will get the value I have up here, which is 16 plus 8 root 5. Okay, so at this point, I am now going to have that my s cube alone is now equal to 2 plus root 5 all over my 16 plus 8 root 5. And then, of course, if I factorize the numerator, the denominator, I'm going to get the value exactly what I have in the numerator, inside my denominator. And what is that? If I bring out 8, and so at this point we can easily take away this and this. Of course you have 1 up here, so that means that my x raised to the power of 3 is simply equal to 1 all over 8. And so if I now take the cube root of both sides, this now means that my x alone is the cube root of 1 over 8. And what is that? That is equal to 1 over 2. Okay, here is another Olympiad maths problem. This question says that what is the sum of all proper, underline the word proper, fractions whose denominators less than or equal to 100. Okay, so in other words, they're asking us to get the sum of all the proper fractions you can get whose denominators, and first of all, what is a proper fraction? So you recall that a proper fraction is a fraction x over y where x and y are members of the integers, especially, in fact, let's use n instead of using integers, are members of n, and also your x must be less than your y. So when this is fulfilled, you say you have a proper fraction. Of course, in this case, we are talking about positive fractions. Okay, so now, so the question is asking us to get the sum of all the possible proper fractions with denominators less than or equal to 100. Okay, so how are we going to get that? Now, it's important that we note that the fractions are going to be stuff like this. This is how it's going to look like. You will have the first one is fractions with their denominators as 2. And that's the only proper one there is half. Okay, so then the next one is with the ones with the denominators as 3. So there you will get 1 over 3, you will get 2 over 3. Okay, the next, if you put 3 over 3, that will be 1, which is not a proper fraction. Okay, and then the next one is the ones with denominators as 4, 1 over 4, 2 over 4, and 3 over 4. Okay, and so on. If you go to 5, you have 1 over 5, 2 all over 5, you have 3 over 5, and then you have 4 all over 5. Okay, and then there is something, of course, it continues this way for all other ones. For denominators as 6, you will always have the numerator to be 1 less than that's the number of fractions you will get will be 1 less than the denominator. So if I have a denominator as 7, I'm expecting 6 fractions. That's a 1 over 7, 2 over 7, up to 6 all over 7. Okay, so of course you will get 6 fractions there. Right, now what's important to us in this place now is how do we now get the sum? Are we going to do this up to 100? How do we do it faster? Remember that Olympiad exam is all about speed and accuracy. Okay, so to be able to do that, we are now going to do a generalization that is going to help us, be able to get our solution. All right, so if I have something like, say, 2.5 all over 5, is this not a proper fraction? Of course, it is a proper fraction, but you must note that no matter what numerator you have, even that numerator, if it happens to be a fraction, that's a decimal, if you convert it, you will still get another fraction, which will still fall under all of these that we are getting. Remember that the next set will be the ones with denominators as 8, the next will be the ones with denominators as 9, 10, 11, 12, down to 100. Okay, for instance, if you look at this one now, you could see that this is the same thing as 5 over 2 all over 5, which is actually the same as 5 over 10, which is actually 1 all over 2. So you would see that all of this will still transform into something that will fall under this category that we are given here. It's a general category. Every fraction will eventually fall into this, so far as it is a number that is expressible as a fraction. Okay, so let's quickly look at what to do now. So the sum we are looking for will eventually be of this form. So you will have half, which is the first one, plus the next one will be 1 over 3, and 2 over 3 will sum together. And then after that, you are now going to have 1 over 4. Okay, that's for the ones that will have denominators as 4. And so it will continue that way. You will have the one that will have denominators as 5. So it will continue that way until you get the ones that will have denominators as 100. So let me end it with 98 over 100 plus 99 all over 100. So it will continue like this until it gets to 99 over 100. Okay, so how do we now get this sum? This is what our duty now is. Okay, so see what we are going to do now. So we'll try to simplify each of them. Now you see that by the time you simplify this, you're going to form a sequence. The first one remains your half, and then the next one, of course, if you add this, you are going to get 3 over 3, which is a whole number. And that 3 over 3 is the same thing as 1. Now, but in this sequence, we want to form a sequence where all the denominators are going to be the same. And that denominator is going to be the first denominator that we have here, which is 2. So how can I write 1 to give me a denominator of 2? And that's easily 2 all over 2. Okay, so we go to the next one. By the time you do this next one, you will definitely get something that will also be over 2. Okay, so if we sum this is going to be 6 over 4. And by the time you reduce this, you will get 3 all over 2. And plus, if you do the one for 5, you are going to just add extra, that's another one, which is 4 over 5. So that will be 1 over 5 plus 2 over 5 up to 4 over 5. And that will eventually give us, if you add everything, you are going to get 6 plus 4, which is, okay, let me write that. So you have 3 all over 5. Then the next will be 4 over 5. So if you add these fractions, you're going to get 10 all over 5. And 10 over 5 is actually equal to 2. So the question now is, how do I now write 2 to be a fraction where the denominator is 2? And that's simply 4 all over 2. So now, if you continue this sequence, it will keep going this way until the last one, that's the fractions where the denominators are 100, is going to give you a total sum of 99 over 2. Okay, so that's what you're going to get. So it's going to form this series. It's actually a series, not just a sequence. So it's going to be a sum of 1 over 2, 2 over 2, 3 over 2, 4 over 2, 5 over 2, 6 over 2, 7 over 2, 8 over 2, down to 99 over 2. I'm going to do that of 7 so that you will see that it's definitely going to give you 7 over 2. Remember that 7 is going to be 1 over 7 plus 2 over 7 up to you keep adding until you get to 6 over 7. Okay, that means I'm going to be adding 1, 2, 3 to 6. So if I add 1 to 2, that's 3 to 4, that's 6 to 5, that's 15, then add 6, that's 21. So you see, you will have 21 over 7, which is equal to 3. All right, okay, sorry. For the one of 7, we are going to rather get 6 over 2. So, of course, by the time, remember, the first one is 1 over 2, and then the ones with their denominators as 3, okay, is 2 over 2. Sorry, the denominator is always 1 bigger than the number you have as your numerator here. So, for 4, is going to be 3 over 2. For 5, for the ones with denominators as 5, is going to be 4 over 2. For the ones with denominators as 7, is going to be 6 over 2. And for the ones with denominators as, you can choose anything. Let's say something like 25. For the ones with denominators as 25, that means it's going to be 24 over 2. Okay, and you can check if this is true. And to do that, we are going to check for this last one, which gave us 99 over 2. Let's see how we got that 99. Remember that it's going to be 1 over 99 plus 2 over 99 plus 3 over 99 down to, you keep going that way until you get to 98 over 99. Sorry, I'm talking about, the one that will give us 99 over 2 is over 100. The denominators will be 100. Okay, so this will be 1 over 100, 2 over 100, 3 over 100, up to 99 all over 100. Okay, so how did we get this sum to give us this 99 over 2? So let's quickly look at it. Of course, if you look at this, you will see that this is actually the same thing as, let me write here. This is actually the same thing as of course, you are summing 1 plus 2 plus 3 down to 99. Everything is over 100. Okay, so you are going to use series and sequence here. 1 plus 2 plus 3 to 99 is the sum of numbers from 1 to 99. So if I use the formula for sum of n terms, that's equal to n over 2 into 2a plus n minus 1. You remember this formula, multiply by d, and then you close your bracket. So this is going to give us our n, remember, is 1 to 99. So our n is 99 all over 2. Then open your bracket. Your first term is 1. So 2 times a, our a is 1, that's 2, plus your number of terms is 99 minus 1. That will give you 98. And what is the common difference? The common difference is simply 1, because of course it's an arithmetic progression. So it's just adding 1, 1, 1, okay? So this is going to give us 99 all over 2 multiplied by this plus this is going to give us 100. Okay? So, but remember that there is over 100. I only summed the numerators. Okay, so you remember you divided by 100, which is this one. All right, and so this 100 will cancel this 100, and so you get 99 over 2. Okay, so that's how this 99 over 2 was gotten. So if you do the same for all others, for the ones with denominators as 10, whatever, you will always get your value. So now our job now is to get the value of this particular series now. So let's try to sum this series. So now you can see everything has denominator as 2. So that means I can bring out half. That's, I can factorize half out. And if I do that, I will have 1. If I bring out half from the second one, I will have 2. If I bring out half from the third one, I will have 3. And it will continue that way, 4, 5, until you get to 99 as well. Okay, and you are done. So simply note that this is the same thing as 1 over 2 multiplied by, remember that I just summed 1 to 99 using series and sequence now. And what did we get there? We got 99 all over 2 multiplied by 100. So this is simply what we will do to finish our solution. So this is going to give us 50 here, and of course 2 again will go here to give us 25. And by the time you multiply these two, you are going to get 2,475, and that is the solution to this problem. All right, it says if 17x plus 51y is equal to 85, that we should find the value of 13x plus 39y. All right, so what does this expect from us? So it is easy to see that first of all, I will be asking myself, can I, is it possible to extract a number that is common to all the numbers I have here. I have 17, 51, and 85. Is it possible to reduce it to any further term? That's a simpler term now, because of course from here you can see that there are two variables, and for you to solve an equation with two variables you would need two equations, and that's when you do it simultaneously. But in this case it's just one equation, and we are then asked to find the value of this. So we'll try to see, is it possible to reduce this equation to something simpler, such that I can also reduce this other one I am asked to find into that same form that will now help me get what I want. And of course I can see that 17 can actually go through the numbers here. So if I divide through by 17, I am going to have x plus, of course, 51 divided by 17 is going to give us 3. So we have 3y is equal to, and also if we divide 85 by 17, we are going to get 5. So you may need to check all of that. So if you multiply 85 by 17, if you multiply 17 by 5, this is 5 carry 3, and then this will give you 85. So of course it is equal to that. So now the next question is to ask myself, is it possible to write this in such a way that I can get x plus 3y, so that by the time I now get that, I can now substitute that value as my 5. And of course you can see that 13x plus 39y is the same thing as, of course, if I factorize 13 here, I'm going to get x plus 3y. Okay, and that makes my work very easy. All right, so because from this place, if I had called this, say, equation 1, so you would see that from equation 1 that x plus 3y is equal to 5. So we'll kindly substitute that as our 5, and when you multiply this, you will get the answer to this question as 65, and that is the solution to this problem. Okay, right, so in this video we are asked to find the value of this we should evaluate. Okay, so you can see that this is actually roots of sorts, and I've done videos on this channel that handled that. So, but of course you know that if we want to take the root of this and then take the root of this and subtract that is going to take a lot of time. And you know that this is from Olympiad exam, and of course it's an exam that deals with time. So what do? We will try to see if it is possible to use another means to get what we are looking for. So you can easily see that the values under the roots here are simply conjugates of each other. And so can I simply give names to these values and see what that does for me? So if I call the first one A, okay, so now from here I can easily now take away the root. Of course, you know, whenever there is root or square root, you know, it's usually a little bit difficult to handle. So can we clear the roots? If we do that, we are going to get that a squared is equal to 2 plus the root of 3. And then if I do the same for b, I will get that b squared is equal to 2 minus the root of 3. And then immediately I am getting these values which are actually conjugates of each other. So, and I can then do something, which is to try to multiply the two of them. And so if I multiply a squared by b squared, I am going to get 2 plus the root of 3 multiplying 2 minus the root of 3. But like I said, these are conjugates of each other, and so you will just square each of them. So you are going to have 2 squared. Of course, there are difference of 2 squares. 2 squares also. So, and then I'll have minus 3 squared. Okay, which is simply going to give me 1, because 2 squared is 4, and the square of the root of 3 will give you 3. Right. So now what do I do next? Okay, so going forward now, from what we have here, remember from my substitution, what we are asked to evaluate now will now be simply a minus b. Okay, so how do I get a minus b? Now you recall that from quadratic equations or quadratic roots, if I take the square of a minus b, of course, this is the same thing as a squared minus 2ab and then plus b squared. Okay, so kindly, of course, when you open this bracket, that's a minus b multiplied by a minus b. If you do that, you would, of course, get this. Okay, so let's now try to substitute what we have. Now, remember, our a is this guy here. Okay, so if we substitute, if we take the square of it, we will simply get 2 plus the root of 3 and then minus 2 into, meanwhile we have gotten our AB now. And how did we do that? Recall that we got a squared, that's this person, a squared b squared, which is the same thing as ab squared, as equal to 1. And if we take the square root to the other, the square to the other side, it becomes square root, which will give us the square root of 1, and so that is equal to 1. So our AB is actually equal to 1. And then finally, we can then have our b squared, which is the square of this. And of course, if you square, you will only get 2 minus the root of 3. Okay, so and then let's now try to evaluate what we have. And if we do that, this is going to give us, and what is this going to do for us? This, of course, will take away this, while this guy will take away this guy. So here we just have 2. Meanwhile, recall that what we are asked to get, this is your a minus b squared. Then what we are asked to get is only a minus b. Remember, we reduce this into a minus b. And so by the time we now get our a minus b, so it means that a minus b will simply be the root of 2, and it is enough to leave it this way as the solution to this problem. All right, this one says that upon solving the systems of equations given here are the systems we are given. We are given x raised to the power of 5 multiplied by y to the power of 17 is equal to r, and then this other one. And we are asked to find the value of x and y. Now, assuming that after solving that this was what x was gotten, sorry, we are not asked to find x and y. We are told that the systems, that's these two systems, were solved, and the person was looking for x and y, and in the end, the person got x to be of this form and y to be of this form. So, and they are saying if this is true, then we should find the value of a plus b plus c plus d, where our a, b, c, and d are the powers of the values r, s, and as given in the equation. So let's try to solve it. So what are they expecting us to do here? Now, first of all, we have two systems or two equations. The first one is x to the power of 5 multiplied by y to the power of 17 to be equal to r. We can call this equation 1. And the second one is x to the power of 2 multiplied by y to the power of 7 to be equal to s. And this is the second equation. And so what are we going to do now? The two solutions they got, that's the x and y, are in terms of s and r. Okay, so in other words, if it is possible to get the value of x here and write it in terms of s and r, then whatever is the power would definitely be equivalent to our a and b. That means we need to get x to be in terms of r over s. So whatever will be the power of r will be your a, and whatever is the power of s will be your b, while we will get y to be in terms of s over r, and whatever is the power of x S in that case will be our C, and the power of R will be our D. Okay, so now to be able to do that, what are we going to do? So we will try, because this is multiplication, we will try to see if we can make one of the powers, one of the variables to have the same powers, and then we'll now divide. Okay, we can do that for X or for Y. Maybe we should do that for X. So in other words, I want to raise the power of X to be this, that's in equation 1, to be the same as that of equation 2. And that's very simple. Just raise equation 1 to the power of 2 and raise equation 2 to the power of 5. Okay, so if I do that, I am going to now have, if I raise everything in this equation 1 to the power of 2, I will have x to the power of 10 and y to the power of 34 to be equal to s to the power of 2. And then I can call this equation 3. And then what it means is, and if I now raise the equation 2 to the power of 5, I will get s to the power of 10, y to the power of 35, and that is equal to s to the power of 5. Remember that the power is going to multiply the already existing powers. Okay, so at this time, this can be called equation 4. Okay, so as it is now, I can actually now divide equation 3 by equation 4, anyone, or equation 4 by equation 3. Okay, maybe we should do it that way. Let's do equation 4 by equation 3. Okay, so from here now, it then means that, of course, you see, this will take away this. So y to the power of 34 will cancel power to 35, and it will remain only 1. So we'll have y alone is equal to s to the power of 5 all over r to the power of 2. So we can call this one star. So we've gotten our y now. So all we need to do now is to get our x. And to be able to get our x, we can substitute y into equation 2. So if we substitute into equation 2, remember that our equation 2 is x squared y to the power of 7 equal to s. That's this one here. Okay, so now we are substituting y. So what it means then is that our x squared, our y now is s to the power of 5. So if we open this bracket, we will now get, okay, so at this point, we'll try to now make x to be the subject by cross multiplying, and that's going to give us x squared alone is equal to, okay, so this will reduce this to 34, and so we'll have r to the power of 14 all over s to the power of 34. So meaning now that our x alone will be equal to, of course, the square root of r to the power of 14 all over s to the power of 34. So remember that square root is the same thing as power half. So it's going to reduce the powers here by half. So this will now be r to the power 7 and s to the power of 17. And that is our x. So from what we did here originally for our y, you can easily now note here that, remember from the question, the powers of your, you can see here that your y is equal to s raised to the power c over r to the power d. And here we got that y is equal to s to the power 5. So that means c is 5 and d is 2. While up here for x, they said x is equal to r to power a and s to the power of b. So that means it implies here that our c is equal to 7 and our d is equal to 17. Okay, so the implication then is that our a plus b plus c plus d will simply be equal to the sum of all that we have gotten. Okay, so if we sum all that we have gotten here, sorry, this is rather our C and D. Okay, so sorry, this is our A and B. Sorry, that's the powers of X. Okay, so if we sum them, we have A is 7, B is 17, and C is 5, while D is 2. So we have 5 plus 2, and if you sum the whole of this, you will get 31. And that's the solution to this problem. Okay, here it says let A and B be distinct real numbers. That means they are different real numbers. We should solve the equation. And remember I said that whenever you're asked to solve an equation, it means we should find the value of the missing number. So here A and B are actually missing, but they've told us that they are real numbers. So we shouldn't bother about those, meaning we should find the value of X. Okay, so let's quickly look at it. Now, if you look at the equation we are given, you would see that the left-hand side is made up of surds. And so, one of the ways I can tackle this is to square both sides. If I square both sides, it will get this equation more complicated because of this minus sign. So if it was only one square root, then if I square both sides, then it takes away the square root on the left. So, but because of this minus sign and two square roots here, so it will get the equation more complicated. So what's the simple thing I would have to do? Okay, so what I'm going to do is to see if it is possible to take the conjugate of the left-hand side. And of course, yes, I can. And to take the conjugate, I will multiply the numerator. Of course, I can form a fraction on this. So I will simply multiply the numerator by the conjugate of this numerator and also do the same for the denominator. Meanwhile, the conjugate is just to change this to positive. Okay, so let's quickly do that. So here I'm going to have the square root of x minus b squared minus the square root of x minus a squared now is multiplied by the conjugate, which is the square root of x minus b squared plus the square root of x minus a squared. Okay, so and then in the denominator we will now have, of course I can still cancel it out and I will get what I have. Now my right hand side will still be a minus b. So what can we do here? So of course, because these are difference of two squares, you have plus minus here and you have plus here. So all we will do now is of course, whenever you have a minus b multiplied by a plus b, this is the same thing as a squared minus b squared. So I'm going to square this one and then minus the square of this, that's all. So that's going to now give us, so by the time I do that, the denominator will still be x minus b squared. Okay, so remember your right hand side will still be a minus b. Okay, so at this point, of course, the square here will take away the square root. The same will happen here. So the numerator is then going to give us all equal to a minus b. Okay, so from here, what are we going to do? We will try to now open this bracket, and by the time we open this bracket, we will get minus x plus a squared. So, and the minus x will cancel this one, and so what we now will get will be a squared will be positive, so let's bring it to the front, then minus b squared all over. Okay, this is equal to a minus b. Okay, now meanwhile, from the numerator, you can see that that is difference of two squares. So that's the same thing as a plus b, into the bracket of a minus b, and that is all over x minus b squared. So what are we now trying to achieve? Remember, our interest is to get x, so we'll try to simplify as much as possible. So if I divide both sides of the equation by a minus b, this will take away this. So here you will just have only one left. So this is then going to give us The numerator will now be a plus b all over the square root of x minus b squared. Okay. Okay, so and this is equal to 1. So at this point, of course, you know this is 1 over 1, and so it means we can cross multiply. And so if I cross multiply, I am going to then get this one will go this way, and this will go this way. So I will have x minus b squared, and then plus the square root of x minus a squared is equal to a plus b. Okay, so at this point, it means now I have two equations that look alike. I can call this equation 1, while the one that was given to me, that's this guy, I can call it equation 1. Okay, now what we are going to do, you can see that the equation 1 actually looks exactly like equation 2. So the only difference is that our equation 2 is here is addition, while the equation 1 is subtraction. While here you also have addition of these two. So this is our equation 2 now. So at this point, what we are now going to do is to look for now how to reduce the radicals that we have. And one of the ways we can do that, we can see that this one now has negative, while the equation 2 has positive. So if I sum these two equations, I will end up eliminating this one. And if I subtract, I will eliminate these two. Okay, so it's my choice to choose what to do. And I think I want to add. Okay, so let me quickly write it here and then I'll take it down. So if I add this, I will then have 2 of this. This is adding to this. So I'll have 2 root x minus b squared. Of course, this will turn to 0. And then if I'm adding this side, we are going to have a plus a, and that will give us 2a. And then minus b will cancel plus b. Okay, so this is what we'll now have. So with this, we should be able to solve and to get, of course, I can push it further here. This will cancel this. So this is going to give me the square root of x minus b squared to be equal to a. Okay, so I will now try to solve that. Okay, so from that, I have square root of x minus b squared equal to a. So at this point, I can take the square root to the other side, and that will give me x minus b squared is equal to a squared. Therefore, my x alone is simply equal to a squared plus b squared. And that is the solution to this problem. So if we have the values of a and b, whatever they are, once you substitute them, you then get the value of your x. All right, so this is where we end it for this video. So this problem says that we should find the value of 3 raised to the power of m all raised to the power of n if this particular equation here holds. That means, so they are saying that, let's take it that what we have here, that m plus n all squared is equal to m squared plus n squared, so that we should find. This is a very simple problem, which of course anybody should be able to do even without any issue at all. So what are you expected to do here? It's obvious that from here now, this is actually not the complete expansion of this. If you go to expansion of brackets or binomial theorems and all of that, because we know that m plus n all squared is actually the same thing as m. So what does that mean? If you expand this, you are supposed to get m squared plus 2mn. Let me take it gradually. So your m will multiply m to give you m squared. M into n will give you mn. And then this m now into this m will give you also mn. And then n into n will be n squared. Okay, so you see what is going to happen here. This is going to be the same as m squared plus 2mn and then plus n squared. So, but these people now decided to keep this silent. And what does that imply? Okay, so the implication is that for this to be equal to this, so it only means that this other guy here, that's this person, is going to be equal to 0. If that doesn't happen, then it's not possible that this will be equal to this. It's not possible. So the meaning is that they are asking us to keep 2mn as equal to 0. Now, the beautiful thing of solving this kind of problems, especially in Olympiad maths, is that it actually allows you the opportunity to think deep and then, see the the possibilities that are available in any problem you're given. And so, if my 2mn is 0. So what it simply means is that mn alone is equal to 0. And then, of course, because mn is 0, why is it so? Because if I divide both sides by 2, I will get 0. So I will then try to simplify what I have here. And how am I going to get that? Now, of course, 3 raised to power m all raised to the power of n is the same thing as 3 raised to the power of mn, because we are told by indices that a raised to the power of x all raised to the power of y by the law of power of power is going to be raised to the power of xy. Your x will multiply your y. And so simply put that your mn is 0, and so the total value required is actually equal to 1. So this problem says we should find the minimum value of the function this. Okay, so now you recall that if I have a Cartesian graph like this, of course, and a function goes this way. So the maximum value is the value of y at this point if traced to the y-axis. Of course, you know that this is your y and this is your x. So while the minimum value is the value of y at this point. Okay, so all right, now how do I get this value if I'm given the function? Okay, so all I need to do is to get the minimum point and then substitute it into this particular function I'm given here. Now, meanwhile, how do we get the minimum point of a particular function? First of all, we need to get the stationary points if it has more than one stationary point. And how do you know the number of stationary points of a given function? Is from the degree of that function. So the number of stationary points is always 1 less than the degree. So here we have the degree as 2. Therefore, the number of stationary points we should expect from this is just 1. Okay, so and what do we mean by stationary point? The turning points, like what I drew here. So you know we have 3 major kinds of turning points: the maximum point, the minimum point, and you have what we call the inflection point. Okay, so remember that we said that your stationary point is gotten from taking the derivative of of y with respect to x and equating that to 0 when you solve. And why is this? Because at the point where there is a turning on the curve, if you take a tangent at that point, it is always parallel to the x-axis. And because it is parallel to the x-axis, it means actually that your y there is a constant. Okay, and if your y is a constant, if you take the derivative of y in order to get the equation of the tangent, you're actually going to get 0. So at the point where there is a stationary or a turning on a particular function, the derivative of that function with respect to the independent variable is always equal to 0. So if you equate it to 0 and solve, you will be able to get the values of your x, and those values are your stationary point or the turning point. And if we do that here, we are going to get that dy dx is going to be equal to 2x plus 8. Okay, and then if I now equate this to 0, I am going to get that my x alone is going to be equal to -4. Of course, your 8 coming here will be -8, and then you divide both sides by 2. Okay, so now having gotten that, if there were 2 of them, we would now be looking for which one is maximum and which one is minimum. Now, since we just have only one, we only have to check whether if this is actually a minimum point, and if it is, then we only substitute it into this function, and whatever we get is our minimum value. And to check if this is a minimum point, all you need to do is to differentiate this again. And if we differentiate it again, that means we're going to have f prime prime of x. Remember that this one is f prime of x. So if we differentiate it again, we get the double prime, and that is going to give us 2. Okay, and then after you've differentiated, you substitute the value you got here, that's the turning point, to know. Now if you substitute and it is positive, then it means that that is a minimum point. But if it is negative, it means it's a maximum point. And if it is 0, it means it's an inflection point. So let's substitute the value here. Of course, if whatever value you put here as your x, you will still get 2, because this is a constant function, right? And so that means, and since 2 is greater than 0, it implies that our negative 4 is a minimum point. Okay, so having seen that, all we need to do now is to substitute that into this function. And so we are going to have that f of negative 4 is going to be equal to negative 4 squared. If we evaluate this, we are going to have 16 minus 32 plus 15, and that is equal to negative 1. And this is the solution to this problem. It says that we should solve the following system. And you know, when you have a system, the implication is that you have at least more than one equation. Okay, so, and the first equation is here, x raised to the power of a fourth plus y to the power of a fifth is equal to 5. And then we have x to the power of 3/4, and then y to the power of 3/5 to be equal to 35. So we have two equations to solve right now. So what do we do? Now, when you're given two equations, it means you're solving them simultaneously, and you want to find a value of x and y that will satisfy the both equations. Okay, so what can we do now? Now, one of the things we can do is to Now, one of the things we can do is to raise the powers of both sides in order to cancel out the fractional powers we have. But that is also going to be difficult because of the addition signs that we have here. So, then in other words, we would have to look for something else. And okay, so one of the things we can do here is to quickly see if we can substitute variables. So I can say, let my x to the power of 1/4 be equal to another variable. Maybe I can call it a. Okay, so now if I call it a, it means that my equation 2, the variable will change. So that is x to the power of 3/4 is now going to become, of course, by indices, this is the same thing as x to the power of 1/4 all raised to the power of 3. So that means that the x variable in equation 2 will now become a to the power of 3. Okay, so we can keep those two. And then we can also say let x to the power of y this time around. We are done with x, so we go to y. So we can say let y to the power of 1/5, which is in equation 1. Let's call it b. And if we do that, it will also affect the y in equation 2. So you recall that, you can see that y in equation 2 is power of 3/5. And so we can write that as power of course, if you follow this method, so this one will now become y to the power of 1/5 all raised to the power of 3. And so our b will also be to the power of 3 here. So in other words, our equations have changed, The first has now become a plus b is equal to 5 as equation 1. And then the second has become a raised to the power of 3 plus b to the power of 3 is equal to 35. And this is now our equation 2. Alright, so what can we do now to be able to solve the equation that we have just gotten now? Okay, so the first thing to note now is that a plus b can be found inside a cube plus b cube. Alright, so if we use a binomial expansion, by the time we expand a plus b all raised to the power of 3, we are going to get a cube plus b cube and then some a plus b, inside it. Okay, let's quickly use expansion of brackets, and so we are going to have a plus b all squared multiplied by a plus b, and of course you know that a plus b all squared is equal to a squared plus 2ab and then plus b squared, all now multiplied by a plus b. Okay, so if you try to expand this, you are now going to get a cubed plus a squared b. I'm multiplying with this first. So I will use it to multiply these two brackets, and I will also use this one. So if I use the second one now, I will have 2a squared b, and it will also multiply b to give me 2ab squared. Okay, and finally I will use b squared to multiply, which will give me ab squared, and then finally I will get b cube. Okay, so if I bring my a cube and b cube together, I will have this plus a b cube. Of course, I will then collect like terms. Now I have a squared and I have a squared b plus this is 2a squared b. Okay, so if I join the two, I'm going to get 3a squared b, and then if I join 2ab squared and this one, I will have 3ab squared. Okay, so finally at this point, I'm going to have my a cube plus b cube, and then here I can factorize 3ab, and then that will give me a plus b into the bracket. Now remember that it is our a plus b all cubed that gave us all of this. All right, so now if you look at our equation 3, so we can choose to now make a cube plus b cube the subject, and if we do that, so we'll now have a cube plus b cube is now equal to, so this is the value of my a cube plus b cube. And now, so from here, I actually have the value of my a plus b. Remember what I said? We can find equation 1 into equation 2. So I can substitute. My a plus b is 5. So I have 5 cubed minus 3ab multiplied by 5 also. Okay, and so this is going to give us 125 minus 15ab. Okay, now remember that from equation 2, let's look at it. From equation 2, our a cube plus b cube is equal to 35. So that means I can write the left hand side as 35. And when I do that, and then I can make this ab the subject, and that's going to give me 15ab. If it comes here, it becomes positive. So this will now mean that ab alone is 90 over 15, and that is equal to 6. So I have another equation. AB is equal to 6 and A plus B is equal to 5. Let me bring that equation 2 down, or equation 1, sorry. Equation 1 says that A plus B is equal to 5. Okay, so now by a mere comparison of equation 1 and 3, you can get the values of A and B. Of course, you know you can solve these two equations now using simultaneous approach, which will now lead us to quadratic equation, and so we will get the values of a and b. But now we can just observe, you know, because you're working with time, we can just observe and then get our answer. You know, since they are saying that a plus b is 5 and a times b is 6, the only two numbers that will do that for us will be, of course, positive ones. That is what we are considering, will be 2 and 3. Okay, so what that means is that my a is equal, can be 2 or 3, and then likewise my b can also be 2 or 3. Okay, so any of them. When my a is 2, now let's put it that way. So when my a is 2, my b is 3, and then when my a is 3, my b is equal to 2. Okay, so each of these will be able to satisfy these two equations that we have here. Now, but recall that they did not ask us to find a and b. We are actually asked to find x and y, because they said we should solve this system, and to solve this system you would need to get the value of x and for y. Now, but we have a relationship between a and x, and we also have a relationship between b and y. So with that relationship, we should be able to get the values of x and y. Let's attempt doing that here. So since my x raised to the power of 1 over 4 is equal to a, and at first my a is equal to 2, so what it means is that my x alone will be 2 to the power of 4, which is equal to 16. And at that point, you know that my y raised to the power of 1 over 5 is equal to b. So, and we got b to be equal to 3 when a is 2. So that means we will now raise it to the power of 5, and that will should give us around 243 or so. I think I'm correct, 243. And so when a is 2 and b is 3, so it means that at that point our x is equal to 16, and our y is equal to 243. Okay, help me confirm that. I think so. However, that's not the only solution. What about when a is 3 and b is 2? Okay, so let's look at that case. So when our a is 3, so it means that x raised to the power of 1 over 4 is equal to 3, and so x alone will be equal to 3 raised to the power of 4. And 3 raised to the power of 4 is 81. And in the same vein, at that point, when a is 3, our b is equal to 2. So that means that our y to the power of 1 over 5 will be equal to 2. Okay, and so our y alone will be equal to 2 to the power of 5. So that means y is equal to 32. And I hope we understand why I do all of this. You know, by rule of indices, if I have this, if I take both sides to the power of 5, 5 will cancel this, and then this one will be raised to the power of 5. That's also the principle I used here. If I raise both sides to the power of 4, 4 will cancel 1 over 4, and so I'll just have 3 to the power of 5, which is as well what I did up there. Now, so the implication now is that my x and y will have two values. Okay, so it is either at first my x is 16 and y is 243, or secondly my x is 81 and my y is 32. Okay, so this is the set of values of our x and y for the system of equation given to us. All right, so that is what I have for you in this video, solving of the system of equation. It's an Olympiad maths problem. Kindly give a thumbs up to this video. do subscribe to our YouTube channel, share our videos to your friends and your colleagues. We will see you in our next video. Bye.